Right? Synthesis reactions mean that we're putting things together. We're either joining together two elements or we're joining together two small molecules. Decomposition reactions are the opposite. We're taking things apart. We're going to split a compound apart into its elements, or we're going to split a compound apart into two smaller compounds. So let's take a look at some examples here. Suppose that we had our old friend water, and we're going to run an electric current through it. Well, in order to get an electric current to run through it, we're going to have to add some salt or some acid or something so that it will conduct the electric current, because pure water will not. What will we get? Well, if you're going to write the balanced chemical equation, you're going to have to begin by writing the formula. Water, of course, is H2O. And tell me the necessary reaction conditions, if you know them. You won't always know them. And it's going to split these apart into elements. It's going to split it apart into hydrogen and oxygen. But wait a minute. Hydrogen and oxygen are both diatomic elements. You're not going to see just one atom of hydrogen by itself. If there's no other possibility, it will hold on to another hydrogen atom and form a pair. And the same for oxygen. Now, of course, it's got to be balanced. 2 atoms of hydrogen, 2 atoms of hydrogen, 1 atom of oxygen, 2 atoms of oxygen. Well, darn. Well, there's no way to reduce this to 1 atom of oxygen, so we're going to have to increase this. We always increase the smaller side. So there's a 2 there to give us 2 atoms of oxygen, 2 atoms of oxygen. But that goofed up our hydrogen. Now we have 2 times 2 is 4 hydrogens, 2 hydrogens. Well, we must be going to wind up with 2 moles of hydrogen. So now we're all balanced. And this indeed will happen if you just add a little acid to some water and drop in a 9-volt battery. You can see the bubbles of hydrogen and oxygen coming off of the terminals of the battery. Alright, suppose that we are going to take sulfuric acid and heat it, which is not really a good idea. Remind me to tell you the story about that. What will happen? Well, sulfuric acid is H2SO4. Poor little Willie is with us no more. What he thought was H2O was H2SO4. Now we have 3 elements here, so you can see it's not going to split simply into 2 elements. This is going to be one of those where we have to break it up into smaller compounds. So if you think back to your synthesis reactions, you'll see that we get an acid when we react a nonmetal oxide with water. And so going the other way, we heat up the acid, we're going to get nonmetal oxide and water. So our nonmetal is going to be sulfur oxide. And let's go ahead and write down the water so that we don't forget it. And then we're going to have to come back and look at that sulfur oxide. Which oxide of sulfur is it going to be? Is it going to be SO2, SO3, one of the weird ones? Well, let's keep things simple. If we take one of these oxygens and use it to make water, how many oxygens will we have left? 3. So it's a good chance this is going to be sulfur trioxide. And indeed it is. Depending on the reaction conditions, how high you heated it and so forth, you may also wind up with sulfur dioxide and a mixture of some other products. But we're going to keep it simple for right now. Alright, let's try one more. Say we've got some aluminum hydroxide. And I'm not sure in what form we're going to have to supply the energy to get this to break apart. But you always have to supply energy to break a chemical bond. Aluminum, oops, let's swap colors so that you can see what am I saying to you and what are you saying back to me. Aluminum has a charge of +3. Hydroxide has a charge of -1, so it's going to take 3 -1s to balance out that +3. When we add energy to it in whatever form it needs to be, are we going to separate into elements? Well, we've got 3 elements here, so probably not. This is going to be another one of those that is going to break apart into 2 smaller molecules. Alright, we had a metal hydroxide being formed from a metal oxide plus water. And so when we decompose that metal hydroxide, we're going to go back to the metal oxide plus water. So our metal oxide will be aluminum oxide. All right, remember aluminum is 3, so that's going to become the subscript on the oxygen. So oxide is -2, so that's going to become the subscript on the aluminum plus water. But is it balanced? 1 atom of aluminum, 2 atoms of aluminum. That's not balanced. So we're going to have to put more aluminum on the side that doesn't have enough. That will give us 2 aluminums. Now we have 2 times 3 is 6 oxygens. 3 of them are being used up here. So we need to use up 3 over here. That will balance out our oxygens. 2 times 3 is 6 hydrogens. 2 times 3 is 6 hydrogens. And there we go. Not bad at all. As long as you've got a good grip on your synthesis reactions, all you need to do is turn them around and you've got your decomposition reactions.